This is the fourth video in our AWS Developer series. In this video, we run a Kinesis test where the Kinesis stream is mapped to a Lambda event. We'll just take a moment to go through the test details. Firstly, we are using the same Lambda function code as we used in the Docker Lambda Java runtime test. Here is a link to that code on GitHub. We previously mentioned how you can map a Lambda function to a Kinesis stream via an event. We set up a Lambda function handler previously to work with just such event JSON as we see here. Kinesis Lambda event are mapped to streams by what's known as the event source ARN. ARN stands for Amazon Resource Name. For the Docker Lambda test, we mapped our source code to the running container via a Docker volume, where the compiled code in the volume was mapped to the container and the appropriate directory. Now we're going to take a significantly different approach. We're going to create the code for our Lambda function programmatically, zip it up, and push it to local stack, and we will use the Docker runtime inside local stack to run our Lambda function when it's triggered by a Kinesis event. Another small but important detail is we will need to update our S3 code, that is, inside our Lambda handler function. When we push data to S3, we will need to push that data over HTTPS. So we will take advantage of the SDK global configuration class to set a system property to disable surge checking. Just to update to this point, the same code as in our previous Lambda function test where we set up a Kinesis event. But now we're going to create the function code programmatically and zip it up and push it into a local stack. When the event is triggered, the Lambda function runs and it pushes data to S3. We need to update our S3 code to configure the system property, disable surge checking, to be false. Our Lambda event is mapped to the Kinesis stream ARN. We'll need to find this programmatically when we create our Lambda function code, pass in the stream ARN as a variable. We have extended the Kinesis test code on GitHub now to include a new module called Lambda. The code in this module performs the following recipe. Using the Shadow Jar plugin for Gradle, we build a fat jar with the function handler code and all the needed dependencies. If we examine the code in the Kotlin file lambdas, we will find three functions. One function takes the shadow jar with the dependencies and the compiled function handler, maps it to a zip file to push to local stack. The second function creates the Kinesis event, and the third function maps that event to the Kinesis stream with the Kinesis ARN. This is the create function code. This code packages up the shadow jar to be a zip file to push to local stack. The function code we see here is an AWS Lambda function tie. Here we can see a block of code that starts by reading the shadow jar into a zip file. And we process all the entries in the zip file from the shadow jar into a byte array, which we will wrap to the function code type here. Once we have our function code type with its byte array, which has the dependencies and the Lambda function code, the AWS SDK will handle all the rest of the details for us. In this code, we create the function that we set up previously from the shadow jar with the dependencies. Here we declare our handler. This handler is specifically set up to handle a Kinesis event where it pushes data to S3. So first we check, does this function exist? If it does, we delete it. Then we create the function. So we're always creating a new function. And this function specifically listens for this event, maps the event to a push to an S3 bucket. Semantically, we're thinking about this function as being a Kinesis event or an S3 event if you like. So we have a Kinesis event JSON coming in and the function maps that to a push to S3. The AWS SDK makes it easy to map our function to the stream. It has a type create event source mapping request. Once we've created this type, it's very easy using the function name, the ARN for the Kinesis stream. Then the SDK client for Lambda, we can create that mapping. So when we use our Kinesis producer, push data into the stream, JSON from the stream is going to get pushed to our Lambda function for processing. A high-level overview. So we have one container, local stack, running a Lambda service, a Kinesis service, and S3. Run our producer, which will create the stream, get the stream arm, put that into our create function code. When the Lambda handler is called over HTTPS, it's going to push data to an S3 bucket. When our Kinesis producer pushes data into the stream, the Lambda function will be called, and that JSON we discussed previously will be passed into our Lambda function handler. This is our Docker Compose file, the only difference being that we've now added the Lambda service, so when local stack runs, it will provide a Lambda function service endpoint. A tool we can use to help check our results is AWS Local, made by the local stack devs, and here is its GitHub repo. For Python, if possible, I try to develop on Ubuntu 19 because it has a very coherent Python-free setup. Setting up a virtual environment on Ubuntu 19 is trivial. With these commands, we can install and activate a virtual environment. Once we've set up and activated our virtual environment, we can install AWS Local and export the environment variable to allow it to talk to local stack over HTTPS. Now we've gone through all the details regarding the test, we're finally ready to actually run the test and look at the output. This is our Docker Compose, as we've discussed before. Because we're only running the producer, we don't need the DynamoDB container. All our environment variables are set up as we discussed. The only difference is now we are including a Lambda service. So it's booting up and you can see it's offering the Lambda service on port 4574 over HTTPS. Now it's ready. So now we can check out what's going on with our AWS Local. So we're going to activate our virtual environment as we discussed. And now we're going to export the environment variable so we can call local stack over HTTPS. Now we're going to list the buckets. There's only one bucket, which is a default internal bucket used by local stack. Now we can set up to run the producer. Our producer is a little bit more complicated now. First we need to get the stream arm using the Java Core SDK for Kinesis, the Kinesis client. Now that our producer has obtained the stream arm, we pass that stream arm into the Lambdas module, that code we discussed before, where we create the function and map the function event to the stream. Now we can run our producer just as before. For this test, for simplicity, we're just going to run our producer as a main class, so we won't bother running it from the jar, we'll just run it from source. The producer only pushes 2 records into the stream, so once it's pushed those 2 records, we wait for the callback, and then the producer will terminate. Now we will go to local stack and look at the output of the test. So we're looking for events getting mapped to the stream, so we can see the event was mapped. The handler passed the event JSON and then created the bucket. And we're looking for the output of the create bucket action. We're looking for the output of the upload data to the bucket. And we can see all that output is there so that we know the test worked okay. We can check with AWS Local just to double check, and we can see the new bucket has been created. Everything worked out as we expected. As we move through these series of tests in these videos, you can see things are becoming increasingly more complicated. And if we were to be running these tests on the actual AWS infrastructure, it would be very time consuming. Tools like LocalStack, AWS Glide, and Docker Lambda can really speed up test-driven development. Writing tests for Amazon code or just running test-driven development type processes are difficult. LocalStack can only take you so far. So you get to a point where you do what you can with LocalStack, then you have to actually run tests on AWS as well. We're going to look at writing infrastructure as code, developing with LocalStack and also on AWS itself.